we will have many SQL tasks, and then we are going to solve them together step by step. And I will be providing you with a lot of free materials. All the content of this course is also available on my website, datawithbara.com. You can use it later as a reference. I will provide you as well with SQL cheat sheet, where you can find all the tasks and the SQL syntaxes, so you don't have to memorize all of them. I've also prepared for this course a database where we're gonna use it in all our tasks and examples during the tutorials. And if you are new to my channel, make sure to subscribe as I upload videos about SQL and Tableau. So now let's jump in and get started. Retrieve all data and columns from customers. So that means our focus here on the customers table, and all data, that means all rows. So we need everything, all rows and all columns. Okay, so now before we start writing our first query, we need to make sure that we are selecting the right database. As you installed my SQL Workbench, you will be getting some default databases. And after that, we installed our database for the tutorials. So to make sure that we are selecting the right one that we need, either you're gonna double click on it, or you're gonna write this statement. So we're gonna write use, then the database name, db SQL tutorial, and then run. So with that, we make sure that we are on the right database so we don't get any errors. All right, so now let's write our query for the task. So we need all the data from the customers. So the first thing that we specify in the SQL statements for the query is select keyword. After that, since we said all the columns, we're gonna use star. Star means all the columns inside this table. After that, we need to tell the database which table that we need. So since we need the customers, we're gonna select the table customers. So we're gonna say from customers. So we have now the query that's gonna select all columns from the table. And here we don't have any like filters or anything. So this is the basics form of SQL. Let's hit run. And as you can see here now, we have the results. We have all 5 customers from the table customers. And don't forget, in SQL, the order is very important. So it always starts with select, then comes from clauses. Because if you do the way around, you will get an error. So make sure that you are getting the right order while you are writing an SQL statement. So now let's do another task where to say, okay, I want to see all the data from orders. So let's do that. All data, all columns, that means select, star, from, and now our table is orders. So I'm gonna select the table orders here and then execute. And as you can see now, we can see the database retrieve 4 orders, and that's right, because this is all what we have in our database. All right, so now you might be saying, I'm not really interested in all the columns from my table. I want to specify few columns from the table to retrieve. So let's say we have the following task. Retrieve only the first name and the country of all customers. So here the difference from the previous one is that we don't need all the columns. We just need few columns. So let's see how we can solve that. So I'm gonna remove this one and start with select. And now I cannot use star because I don't want to have all the columns. So we are interested on the first name. So we write down first name, then comma. The second one is country. And now we need to tell the database from which table. So from customers. And let's run. As you can see here now, we have only 2 columns, first name and country, and we don't see here the other columns like customer ID or score. So with that, we selected only 2 columns without using star. List all countries of all customers without duplicates. All right, so now let's try to figure out how we're gonna solve this task. As we can see, we need the customers. That means we're gonna focus on the table customers, and we need all the countries. That means we need only one column called country. So let's do a basic query. We're gonna start always with select, and the column that we need called country. So we're gonna write down country. Then from our table is customers. So now let's just check whether there is any duplicates and see the results. So execute, and now we can see the results. Germany, USA, UK, Germany, USA. As you can see, there is duplicates. We have Germany twice, and as well the same, we have USA twice. So now the task is saying without having any duplicates. So in order to solve that, we're gonna type distinct exactly after the select. So we're gonna use distinct over here, and this keyword always comes after select. And only by doing that, it's like magic words, it's gonna remove all the duplicates. So let's check that. So execute. As you can see, now the list contains only unique entries. We have Germany only once, USA as well, and UK as well. So here we have a unique list of all countries, of all customers, and we solve the task. Retrieve all the customers where the results are sorted by scores, and the smallest should be first. So now let's try to figure out how we're gonna write the SQL statement in order to solve these tasks. So now, since we need the customers, that means we are focusing on the table customers. Let's write our select statement first. So select, there is no specifications about the columns. I'm gonna use a star from customers. So let's run that and see. As you can see, we have all the customers, but as you can see, it is not sorted by the score. The task is to sort it by the score. The smallest first, then come the highest. In order to do that, we're gonna use the keyword order by. So let's have a new line, order by. After that, we need to specify the column that we're gonna use to sort our data. The task says it should be sorted by score. That means our column is score. So the column name, score. Now we have here two options how we're gonna sort our data. We have two ways, ascending and descending. In the task, it says it should be sorted by score, the smallest first. That means we need to use ascending. In SQL, we have the keyword ASC. That means it is ascending. So now we have the order by clause and we should be fine. Let's run the query. Now, if you check the result, you already might notice that the result is sorted differently from the start. That means we have different sorting now after the score. So the first one is null. It's because the null considered to be the smallest in sorting. After that, we have 350. It's the smallest score from all those customers. Then comes the higher and higher and so on. So now we put a rule how to sort our data, and we have solution for our task. One more thing to notice is that in SQL, the default sorting in order by is ascending. That means if I go here and remove the ask, this keyword, and start the query again, I will get exactly the same results because if I don't specify anything after the column name, the default gonna be ascending. Okay, so now let's consider one more quick task, and it says almost the same. Retrieve all customers and the result should be sorted by score, but this time the highest should be first. So that means we need to use the method of descending, the highest first and the smallest. So that means we have the same query, we don't have to change anything, but now after the column name, if I leave it empty, it's gonna be ascending, but this time we need to be using descending. So we're gonna use this keyword, disc, that means descending. So let's run this query. So now let's check the result. We can see already that the list is sorted the way around. So now we have the first record with the highest score. John has 900 and it is the highest. Then come the smallest and so on. So now we are sorting the list or the result with the descending way. All right, so now using order by, sometimes it gets a little bit more complicated if you are using not only one column, maybe different columns to sort your results, especially if you have a lot of duplicates inside your data. So using one column will not help you. You're gonna end up using multi-columns in the order by. So in order to understand that, we're gonna have the following task. Retrieve all the customers where the result is sorted by country in alphabetical order, and then by score where the highest is first. So let's try to figure out how to write the SQL for that step by step. So now I'm gonna remove everything over here. I write it down, order by the first one called country. So the column we need is country. Alphabetical order, that means it is ascending. So we could leave it as a default or we could write ask. Doesn't matter. We're gonna have the same result. So now let's check the result for that. So now as you can see that we have the results already sorted by country in ascending way, that everything is fine. So we have Germany first, then UK and USA. So it's already sorted, but that is not enough because the task, it says, okay, after that, you need to sort it by the score, the highest first. If you check now here the example, those two customers, Maria and Martin, both of them comes from Germany, but Maria comes as first, and even though that she has lower score. So that means after we sorted with the country, we need to sort again those scores. So in order to do that, we're gonna put here comma, and then write down the score. Then the option here gonna be descending, the highest first. So disk. So that means we could use in the order by here 2 columns, and for each column we could use different methods in order how to sort it. So now let's run this. And as you can see here again, that's okay, we have it sorted by country, but now Martin comes first because he is higher score than Maria. And this is exactly how we're gonna like sort the data using multi-columns. List only German customers. So that means we are not interested in all customers. We need to see in the results only the customers that comes from Germany. Okay, so now let's try to figure out how we're gonna solve this task using SQL query. In the task, we will be focusing on the customers. That means we will be querying the customers table. And since there is no specifications about the columns, we could go and retrieve all the columns. So let's try to write now the SQL statement for that. So select as usual, then no specifications about the columns. We're gonna select everything. We use star. From our table is customers. And let's run this and see. As usual, we have all the data, all the customers from Germany, from USA, UK, and so on. But the task says only the German customers. That means we have to do some filters now. In order to do that, we're gonna use the where clause, and usually we put it immediately after from. All right, so now we need to write down the keyword where. After the where, we need to specify our condition. The condition should be based on the countries. That means country should be equal to Germany. So we write down now the column name country, equal operator, and now here we need to enter the value that is exactly like it's written inside the database, Germany, like this. So we write down Germany. So let's start now the execution and see the result. As you can see, we don't have all the customers. We have only 2 customers that fulfill this condition, Maria and Martin. Other customers like John, George, and Peter, they all don't fulfill the condition and they are excluded from the results. All right, so as you can see, SQL is pretty easy to write and read. Like, check this, select all columns from customers where the customer's country should be equal to Germany. So it's really easy to read. It's using English words and in the logical order. Okay, let's have now another quick task. It says, select customers whose score is greater than 500. So it's based on the same table, so we will not change here a lot of stuff. The only part that's changed is the condition. So now we're gonna remove this here. Our condition here is based on the score. So we have the column score. The operator is not anymore equal, it should be greater, so we need another operator, and the value is 500. So we write down here 500, let's execute that, and now we can see the customers whose score is greater than 500. As you can see, it's pretty easy to use the where statement. Find all customers whose score is less than 500. So that means we're gonna focus on the customers table, and there is no specifications about the columns. We're gonna use select star from customers. So now let's run this. As you can see, we have all the customers, but we need to filter the data, score less than 500. So we're gonna use the where clause. The column is score, the less operator, and then we're gonna type 500. So let's check the results and run it. So we have only one customer whose score is less than 500. Find all customers whose score is less than or equal to 500. So almost the same, but we have here as well the customers that are equal to 500. So let's check that. We're gonna have the same query, so we'll not change anything over here, only the operator. So we need the less than, so it's gonna stay like this, but we need as well equal to. So there's another operator that's called less than equal to, and it looks like this. So we have them both like this, and let's query and see the result. So as you can see, now we have the customer number 4, Martin. He has scored 500, and now it should be shown on the result. So we have the first one, Maria, less than 500, and we have Martin. It has exactly like the 500. So this is the less than equal to. So as you can see, it's pretty simple. Let's go with another operator with the following task. Find all customers whose score is higher or equal to 500. So that means it's almost the same, but we need to use the other operator, greater than equal to. So it looks like this, greater or higher than equal, and let's check the result. So as you can see here, now we have all those scores that are higher than 500. So we have John with 900. We have George with 750, and Martin stays here because his score is equal to 500. So as you can see, it's really easy. Find all non-German customers. So let's try to solve that. We're gonna stay with the table customers. So select star from customers, and we need to filter now the data using not score, but the country. So we're gonna type now here, country. And since it says non-German customers, that means the country should not be equal to Germany. So the not equal operator, it looks like this. And then we need the value Germany. So with this query, you are saying, okay, give me all the customers whose country is not equal to Germany. So let's run that. And as you can see here, we don't have a country called Germany in the results. And you could see like or have the same result using this operator as well. It says as well not equal. So if I run that, we're gonna get the same result. So you could use either one of them. There is no difference between them. Find all customers who comes from Germany and their score is less than 400. So we have here two conditions. Let's try to solve that. So as usual, we're gonna use select. No specifications about the columns, star from our table is customers. And now in the where condition, we have two conditions. So the country is Germany. So we're gonna write country equal the value Germany. And now we have another conditions. It says the score should be less than 400. So score less operator 400. So now I have two conditions and I need to combine them. In the task it says and, that means both of the conditions should be fulfilled. So I need to write now the operator and between both of those conditions. So let's run this and see. So with these conditions, we have only one customer that fulfill both of the conditions. So we have Maria, come from Germany, and her score is less than 400. Find all customers that come from Germany or their score is less than 400. So we have almost the same setup, but here we have the logical operator or. So we have the same conditions, country equals Germany, score less than 400, but now we're gonna connect them with the OR operator. So now let's check the results. I'm gonna execute that. And as you might already noticed, we have now two customers like as a result for these setups. Find all customers whose score is not less than 400. So that means we have only one condition and we have the not. So let's try to solve that. So here we have only one condition. It is about the score. So it didn't say anything about the country. I'm gonna remove this part of it. So we have score is less than 400, but it says it should not be less than 400. So all what we can do is just to add the not operator. It's very simple. So let's run this. As you can see over here, that's all customers, they don't have score less than 400. Find all customers whose score falls within the range of 100 and 500. So let's try to solve that with SQL. So as usual, select star. There is no specifications about the columns. Our table is customers. And now we need to filter the data. So we're going to use where. And here, the column that we need to use is score because it says score should be between 100 and 500. So we're going to write down score. And now the syntax for between, you need to write the keyword between. And here now we need to specify the minimal value. So the min value, the first boundary, is the 100. And then we're going to use the operator and then the max value. And that's it. So for the between, you need to write down the column name, between, min value, and max value. So that's it. Let's now try to execute the query and see the results. As you can see, those two customers have the scores that is between 100 and 500. Find customers whose customer ID equal to one of the values 1, 2, or 5. So let's try to solve that. As usual, there is no specifications about the columns, so we're gonna select star from customers, and now we need to filter the data. So we're gonna use where clause, and here we start. So it says the customer ID. So that means this is the column that we're gonna use in order to filter the data. So customer ID. And now we have a set of values, 1, 2, and 5. So in order to use that, we're gonna use the in operator. And we start defining now the list, the checklist. So open brackets. The first value is 1, then comma, 2, comma, 5, then close brackets. So we defined the list of values that we want to see at the results. And with that, we're gonna run the query and see what's gonna happen. So as you can see, the query is run and we have the list of customers that exactly match our list. The customer ID 1, 2, and 5. All right, so you might tell me now, wait a minute, Para. I just learned about the OR operator and how I combine different conditions using the OR. And I could solve this task using that instead of using in and like a checklist. So let's see how we could do that. I agree, it's gonna work as well. So select star from customers where customer ID equal to 1. So the first one. Then we write or customer ID equal to 2. And go on. Customer ID equal to 5. So if I run this query, we will get exactly the same results. But like I agree on that, but as you can see here, it is more compact and much easier to read. Like you make a list and that's it. Here you can define all those values with like multiple conditions and connect them with the OR. So imagine you have 10 values, you will have here 10 rows of codes. So I really like it with the in operator. It is more compact and easier to read. Find all customers whose first name starts with M. So as usual, we're gonna select star. No specifications about the columns. Our table is customers, and now we have to filter the data with our pattern. So where clause, the column that we're gonna use in our pattern is the first name. Then we're gonna write down the like keyword. After that, we're gonna specify now the pattern. So it starts with the high comma, then big M, %, and then close it with the high comma. So with that, we specify the pattern for the like operator, and let's run it. So as you can see in the results, we got those 2 customers that have a big M at the start of the first name. So this is how we're gonna do it using the like operator. So the next one, it says, find all customers whose first names ends with a small n. So we're gonna have the same stuff over here, but we need to redefine the pattern. So hoch comma, high comma, that was in German, and then anything like the percent, and then small n. Then close it. So let's run that. And as you can see, we got those 2 customers, John and Martin, because they have their first name and they end up with the N. Find customers whose first names containing somewhere an R, small r. So let's do that. So we're gonna have the same setup over here, but we need to change the pattern. So high comma, then percent, small r, percent, then high comma. With that, as I said, you are not specifying any position. Somewhere should be an R. So let's run that and check our query. You can see here, Maria has an R somewhere, George has an R somewhere, Martin and Beta. So we got those 4 customers, but John, we didn't get him because he don't have an R in his first name. Find all customers where the first names containing the R character at the 3rd position. So here, the same stuff over here, we need to change only the pattern. So high comma, the first character should be anything. So underscore, again underscore, the second character could be anything. And here we define the R. And then we say anything after that. Then high comma, it's only once. So we write down here the pattern after the like, and let's run that. And as you can see, only Maria and Martin, as we discussed that, containing the 3rd character, the R. Find all customer ID, first name, order ID, the order quantity, excluding those customers who didn't place any orders. So in this example, as you see, it is not only the customers, we need some columns from the customers tables and some columns from the order tables, and we have to join them in order to do that. So let's start doing that step by step using SQL. So first we're going to start with the select. Since in the task it is like specifying the columns, we will not use the star. So select, we need the customer ID, then the first name, and the order ID and quantity. So now we need to specify the tables. We're gonna start from the customers. With the inner join here, it doesn't matter whether you are starting from left or from right. So I'm gonna start from the customers. And now, in order to specify the second table, we're gonna use the join statements. So we're gonna say inner join. And with that, I'm saying, okay, we're gonna join now the customers with another table. So we're gonna inner join the orders. With that, you are connecting 2 tables, the customers and the orders. As I said, you need to specify 2 things, the join type and the join key. We have already here specified the inner join because we don't need those customers that didn't place any orders. So we're going to use the inner join over here. And the second thing that you need to specify here, what is the join key? How are you going to connect those tables? You need to specify that for SQL in order to do that. So we're going to now go to the new line and say on. So the joining on those columns. So in order to specify the columns, I'm going to give now only some aliases. So instead of customers, I'm going to say, okay, I'm going to call you C. And instead of orders, I'm gonna call you as O. So now in order to join those tables, we need to find out what is our join key. Which column here exists in both of the tables. So we can see the customer ID, we can find it in the customers and in the orders, and it is the perfect column to join those tables. So we're gonna connect both of them with the on. So I'm gonna say, okay, let's take the customer ID from customers. It should equal to the customer ID in the orders. So O.customer ID. With that, I specify the rule or the key how the table is going to be joined. I said the customer ID from the left table should be exactly the customer ID from the right table, from customers and orders. And with that, I specified the rule. I specified over here as well the join type. And with that, we connected two tables. All right, so now before I go and run this query, we still have one problem, and is that the customer ID in the select, I didn't specify from which table. And if I run it like this, we will get an error. You could try it. But now we need to specify which customer ID I want. Is it from the customers or from the orders? So in order to do that, we're gonna use the C dot the table name or the alias in order to specify, okay, I want the customer ID from the customers. For the rest, you don't need to do that because it is a unique name, like the first name, it's unique column name only in the customers. But I really recommend you, once you are trying like to join some tables, it is very nice way to document your stuff to say, okay, the first name, it is from the customers, because with the time you could forget that, or if you don't understand or don't know the data model, it will be hard to understand whether, okay, is this first name in the customers or in the orders. So it's really nice way to document that if you put just the table name or the alias at the start. With that, you could see very quickly, okay, those two columns come from the orders and those two columns come from the customers. And one more thing to make it look nicer, I'm just gonna use tab. So now we are ready, I think. Let's try to query that. So as you can see now in the results, we got the columns from both of the tables. So we have the customer ID, the first name from customers, the order ID, and the quantity from the orders. Find all customer ID, first name, order ID, quantity, but include those customers who didn't place any orders. So for us, that means we need to see at the result all the customers, not only those customers that did place an order, but all the customers. In order to do that, we're gonna use the left join. So we're gonna have exactly the same query, there's nothing is changed, the same columns, the same tables, but instead of saying inner join, we're gonna work with the left join. And saying left join, that means, okay, for the SQL, it's gonna list all the customers. So let's see what's gonna happen if we do that. Let me make it bigger a little bit. So as you can see here, as I said left join, we have all the informations from the customers and only the matching ones from the orders. Find all customer ID, first name, order ID, quantity, but this time include all orders, regardless of whether there is a matching customers. That means for us, okay, we need all the orders from the right table, from the orders. And in order to do that, we have the same setup over here in SQL. We just need to change the type of join. So we're gonna write here, right. Once you do that, you are controlling, okay, how the database is gonna match and gonna present the results. We will have the same setup over here, will not change anything, and let's run this. And with that, you can see, okay, the database did list all the orders from the order table, and from the left side, only the matching customers. List customer ID, first name, order ID, quantity, but this time include everything. All orders and all customers. Okay, with the full join, I have two things to say. First is that the full join is only supported in some databases, like Microsoft SQL. So with MySQL or Oracle, you could not use the full join, but instead of that, I'm going to show you some workaround how to do full join with MySQL, so don't worry about it, but we need to twist some stuff in order to create the full join. If you are using Microsoft SQL, you can just go and say full join. The second thing is that full join has sometimes bad performance if you have big tables. So try really to avoid using the full join. In my projects, I always tend to use like inner join, left join, right join, or full outer joins. I really try to avoid using that. Full join has really bad performance. So if you have small tables, it should not be a problem. But once the table gets like big, the full join is gonna be really slow because you are saying, okay, give me everything from left, give everything from right. And that has sometimes bad performance. So try to avoid that. So now the question, how are we gonna do full join if we don't have in MySQL a full keyword? In order to do that, as I said, we're gonna use some workaround. So follow me in this. So a full join is actually a combination between a left and right. So left join plus right join. So what I'm gonna do, I'm just gonna go and duplicate this script. So we have twice the same query, but one we say left join and in the other we say right join. As the next tutorial, we're gonna talk about how to combine two statements in one. So in order to do that, we will use the keyword union. So once I put union, I'm just like adding two statements in one. So here I'm saying, okay, give me all the results from the left and combine it with the result from right. And if you execute it, you will get exactly the same result as the full join. So with that, you could see, okay, here I have all the customers and here as well, I have all the orders. So we have here a full join. All right, make a list of all persons from customers and from employees where we have the first name, last name, and the country. So this is really easy to do in SQL. All what we're gonna do is that we're gonna write two queries, one for customers, one for employees, and then just put union between them and we're gonna get the results. So let's try building the first one. So select first name, last name, and we need the country from customers. So this is the first query. Let's just execute that and see. Okay, now I have a list from the customers. And then we're gonna write that again for the employees. So select. In employees, we have as well first name, last name, and emp country from employees. So let's run the query and see. So now we have the list from employees. So as you can see, we have now two queries, one for customers and one employees. In order to do the union, like to maintain all the duplicates as well, we're gonna write the keyword between them, union all. So now we're gonna run the whole thing and let's check. So with that, we got all the first name, last name, country from both of the tables, from customers and employees. And as you can see, this list contains duplicates because, for example, John is in customer as well in the employees. So if we wish like to remove such a duplicates between customers and employees or add the results, we just remove the all from here. We just use the union. So let's run that again. So now we're gonna get a unique list of information. So John can only happen once over here. So this is how we're gonna do it in union. Find the total number of customers in the database. Okay, so let's solve that using SQL. First, I want to get like all the data from the table customers. We usually do that using select star from customers. So that is easy. Now we can see, okay, we have 5 customers at the table, but the task, it says, find the total number of customers. That means I want to see as a result only the number 5, the total number of customers. So in order to do that, we're gonna use the function count. So after the select, I'm gonna type here the keyword count, open brackets and close brackets. And inside the count, you could specify either star or the name of the column. So let's see with the star. And execute that. And as you can see now, we got like 5 as the raw numbers of customers in the table. So here we have now counted how many customers do we have. But as you can see here, the name of the column, I don't really like it. It's like the function name. So let's rename it for the results as total customers. So let's re-execute that. And now it looks better. So the total number of customers, we have it as 5. As I said, we could use here like star or a column name. find the total quantity of all orders. So that means we're gonna focus on the table orders and we're gonna summarize all the quantities of all orders. It's really easy. Let's do that. So first of all, I would like always to start with the star from orders. And let's run this. So now I have here the table orders and we're gonna focus on the quantity and we have to summarize it. So in order to do that, we're gonna use the keyword sum, open brackets, and now type here quantity, close brackets, and run this. So with that, you got the total number or the total of the quantity. We summarized all the rows in one cell. So here, as usual, we have this ugly name over here. So we're gonna rename it sum quantity. Run it again. So now we have better name as the result. So the sum of the quantity we have here, 2,650. Okay, so now let's move to the next one. We have the average. The average is one more aggregate function in SQL, and you could use it in order to find the average of one column. It is almost the same as sum, so it works with the columns that has some numbers. It will not work the average if you use it on the first name or last name. There is characters, so only on the numbers. But the only difference is that's how average gonna deal with the nulls. So for example, over here we have the null in the score. It will not consider it as a 0 as a sum, but it will ignore it completely, because if it's considered as a 0, it's gonna be a really problem using the average function. So in average, the nulls will be completely ignored. So let's have the following example or the task: find the average score of all customers. So let's try to solve that. We will be focusing on the table customers. As usual, I'm just going to select everything to check the result over here. So we need the column score and we need the average of those values. So in order to do that, we're going to write the keyword average, open brackets, and then the column name and close brackets. So let's run this. So with that, you got the average score of all customers. The nulls are ignored, and I like to rename it. So as average score, run it again. So it looks better now. We have the average score, 625. Find the highest score, the maximum score in our customers table. We have the same table over here. So I'm going to remove the average, select the data. So I want to get the highest score. So this should be John. In order to do that, we're going to use the function max, open bracket, score, close brackets, and run this. If we do that, we're going to get the 900, and that is true. Just going to rename the column. So let's run that again. We have the max score as 900. List all customers' name, where the customer name is a combination between first name and last name in one column. So let's try to do that. So we need the list of all customers' names. We have here first name, and we have as well the last name from customers. So if I execute this query, I will get the following. So we have now a list of all customers' names, but now we didn't solve really the tasks, because the task says we want to have customer name where the first name and the last name in one column. And as you can see here, we have it separated in the database. So in order now to connect those two strings in one, we're gonna use the function concat. So let's see how we're gonna do that. So we need the keyword concat, open brackets, and here we're gonna list the first column, first name, comma, last name. So I'm gonna remove those here, and let's see the result. So as you can see, okay, now we have the first name and the last name together in one column. So if we want to separate them as well from each other, we could use one more string. I'm gonna put the minus between them. So I'm now connecting three strings. The first name, minus, this is from me, and then the last name. So let's check how it's gonna look like. So as you can see, Maria minus Kramer. So with that, we have like a list of all customers' names with the first name and the last name on it. But I just want to rename it as well to the customer name. We make it smaller. All right, so let's query that. As you can see now, we have a column called customer names, and we have exactly the information that we need. So if you want to connect like 2 strings or more strings, you could use the functions concate. So another task that might be, okay, I want all the first names to be in uppercase or in lowercase. So let's see how we can do that. So now we're gonna remove this, and we're gonna now transfer the first name to uppercase. So if I just query now the first name, you can see it is not uppercase, it starts with big M, then the rest are small. So in order to convert everything to uppercase, we're gonna use the keyword or the function upper, brackets, close it, and I'm gonna rename it to upper first name. Let's run this. And as you can see now, all the names now with the uppercase. For some reason, if you want to calculate how many characters do we have the last name, we could do it like this. I'm just gonna extend our query to calculate that. So in order to do that, we're gonna use the keyword length, and inside it, we're gonna put the last name to calculate how many characters do we have there. I'm just gonna rename it to Lin last name. So let's run the query, and you can see the database already calculated how many characters do we have in the last names. So I'm gonna remove the old part over here. So I'm gonna write the same function, so substring, and we need to define now the column name is the last name. The starting position is 2. The links or how many steps is 3. So let's call it sub last name, and let's run this and see the results. So if we check the result now, we can see that we don't have the whole last name, but only a part of it because we defined the substring on it. So instead of Kramer, we have only Ram. So it started with the position 2, and we cut 3 characters. So RAM. From Steel, we started with T, and we have EE. Find the total number of customers for each country. So that means we need to group up the customers by the column country. So we're gonna build this step by step. So we're gonna start with the select star from customers just to check what we have in the customers as usual. So now we need to count how many customers do we have, and with that we learned we're gonna use the function count, and we're gonna close it like this. I'm just gonna rename it as a total customers. So let's run this. So now we have the total number of customers by 5, but now we want it to be divided on the countries, to group up by the country. In order to do that, we're gonna use the clause now group by, so group by keywords, and after that we're gonna name the column that we want to group by. So in our example, it is the column country. But this is not enough. We want to include it as well as the select statement. So in order to do that, let me just select as well the country. So with that, we say it's okay. I want to count the total number of customers together with the country, and then group it by the country. So let's run this. And as you can see now, we have not only the total number of customers, we have as well the country, and the customers are grouped up by the values of the country. So in Germany, we have 2 customers. In USA, we have as well 2 customers. And in UK, we have 1 customer. So with that, we did the total number of customers by specific column. I want the same results, but the total number of customers should be sorted with the lowest first, then the highest. So in order to do that, we're going to use the order by, and here it's very important that the order by comes after the group by. So order by, we are ordering by the count star. So the total number of customers. And here you could use the ask or without it because it is the default. So let's execute this and you can see, okay, the result is sorted now by the total customers, where the lowest first and then the highest. Okay, so now let's have another example for the group by, and the task says find the highest score for each country. So this time we don't need the count function, we need the max function. As you notice already with the group by, we need always those aggregate functions, but it is not a must. So let's try that in the scratch. So select star from, oh, let's make it big, customers. And we want now the highest score. So we're going to use the function max, open bracket. Our column is score. And we're going to rename it max score. So this is not enough because if I execute this query, I'm going to get the highest score of all countries. But this time we need to like group it by the country. So in order to do that, I'm going to list in the select the country. And let's make it more beautiful. And then use the clause group by country. So with that, I'm finding now the highest score for each country. So let's run this. And with that, you can see, okay, the highest score in Germany is 500. The highest score in USA is 900. And for UK is 750. Find the total number of customers for each country, but include those countries that has more than one customer. So that means we have here like a condition to filter our data. So let's try to solve that using SQL. So as usual, we're going to start with querying our data. We're going to focus on the table customers over here. So now we need now to have the total number of customers by country. That means I need to do group by and use the aggregate function count. So like before, I'm going to use the keyword count star and rename it to look good at the result. So count, or we call it total customers. And since we're going to group by country, we have to include the country as a select. And after that, we're just going to like group by the country. So let's run this. We see at the result, we have now all the countries and we have the total number of customers. But our task is not solved yet because we still have a country where its total number of customers is not greater than 1. So we need to filter this data. In order to do that with the group by, we're going to use the clause having. And think about it, it is like exactly like the where clause. We're going to write down one condition. So our condition says the total number of customers should be greater than 1. So the total number, that means the count, should be greater than 1. So we have defined our condition. It's exactly like the where clause. And let's run this. And as you can see, we don't have now the UK with the one customer. We have now all the customers aggregated by the country and only the country that has more than one customer in the result. With that, we filtered our data and we have exactly what we want. Find all orders that are placed from customers with a score higher than 500, but using the customer ID. So let's try to solve that. So that means we're going to focus on both of the tables, orders and customers. And since at the end result, we should present all the orders, I'm going to start with that query first. So we're going to say select star from orders. So as you can see, we have now all the orders, but the task says it should contain only the customers that has higher than 500 as a score. So that means I need to find out which customer's ID over here has a score higher than 500. In order to do that, we need to check another table. So select star from customers. And now we need to put the filter that we need. So where score is higher than 500. So let's run this. You could like run this separately if you highlight it and then execute. So with that, we know that, okay, customer ID 2 and 3 are the customers with the score higher than 500. So I could go back to my original query and make this filter. So I'm going to say where customer ID, I would say in 2 and 3. So with that, with this filter, I'm saying, okay, those customers had a higher score than 500. So let's run only the order bars and check the results. Now I have the orders for those customers. And with that, I solve the query. And now comes the but. This is really bad to do because it has two problems. First of all, I went to another table. I found out those IDs manually. So it was like, we can do it with small table, but imagine if you have like big table with a lot of IDs. So you need to get them extra in the next query. And sometimes it is almost impossible. So with this small example, it is okay, but with big tables, this is impossible to do. Second problem is that once you are having changing data, for example, we are getting more customers, we are getting more orders. That means each time like I'm getting new data in my tables, I'm gonna go and check the query over here and like adjust our query. This is not dynamic, so this is really bad. So instead of that, we're gonna do small trick that's gonna solve everything and make our life easier with the sub queries. So instead of having those static numbers in the filter over here, I'm gonna remove them. And instead of that, I'm gonna say this query gonna be my sub query and this over here gonna be my main query. So the results that I'm getting over here, let's check that again. So the results that I'm getting over here, it's gonna be like feeding the other query. So for that, what I need is really to have 2 and 3. I just need the customer ID, so I don't need all those columns. So instead of the star, I'm gonna say customer ID. Let's run this again. And as you can see, we have now 2 and 3. So it doesn't matter how many like new customers I'm gonna get, I'm gonna always have a full and right list for the next query. So what I'm gonna do, I'm just gonna like cut it and paste it over here. I'm just gonna put it in a new line so it looks much better. So with that, I embedded one query in the next one. So this is the subquery. It has always those open brackets and close brackets. With that, I'm indicating for SQL, we have here a subquery and here we have the main query. So let's run this and check the results. So as you can see, I got exactly those orders from the customers whose score is higher than 500. And now we could have new orders, new customers. I don't have to deal with that. Always my query will solve my problem and I don't have to add all those IDs in the in. Instead of that, we're gonna have it very dynamically and very powerful. So this is much better solution than having like static IDs inside the in statements, and we are very dynamically. If you like just go through that and do more nested queries and so on, you will be able to solve a lot of complex and important tasks using SQL. All right, so now we're gonna try to solve the same tasks using exists. Exist is a little bit different than in, like both of them you're gonna get the same result, but with exists, you're gonna get better performance if you're having like big tables. So if you're having big tables and you are suffering with performance from the in operator, you could start using the exist and to check whether you will have better performance. So we tend to use exist more than in if you are facing performance problems, but it is a little bit more complicated than the exist because there is no clear separations between the query 1 and query 2 or the subquery and main query. So let's see how we're gonna do that using exist. I'm gonna open a new tab. So we will have the same setup. So select star from orders, but now we're gonna have some like aliases because it is something like joins. So I'm gonna have the name O as alias for the orders. And now we're gonna type the filter. So where, then after that, we're gonna type exactly the exists statements. Where exists, then we will have the sub query. So now we're gonna write the subquery. So we're gonna select, and now here we could write anything as columns. So the exist will not depend on the selected columns over here. So you could write anything like customer ID or star or anything you want. We tend in SQL to write just one. So because we don't care about that. Just to make sure that the result from the SQL subquery is not important. It is like the join. So select one from customers. I will give it a name, C. Now we need to add the filter, and here it is exactly like you are doing the joins. So C customer ID equals to orders customer ID. So as I said, it's like a join. And after that, we have another filter on the customers, and is that we need the score to be higher than 500. So with that, we have over here our subquery. It looks a little bit like complicated compared to the in. So here we have like some kind of like inner join. I cannot run this part of SQL. I will get an error because I have such a kind of like those conversion between the IDs. So in order to get the result, I need to run the whole thing. So let's see and run this. You can see I got exactly the same results. And we're gonna start using the insert. So I'm gonna type here insert into keyword, and then we have to specify the table name where we're gonna insert our data in the table customers. Then we have now to specify the values for each column. So values, open brackets, and now we're gonna start one by one. So the customer ID, I want to check that again. The customer ID is integer, it is the primary key, and auto increment. That means the database is gonna like increment the new ID. I don't have to do it myself. So I could go and say default. Defaults means the database is gonna take care of that and gonna insert the customer ID 6. You could go and say, okay, instead of that, I'm gonna type number 6, but I really don't recommend it because if you have like big database and someone else is doing insert, or you forget about what is the last customer ID we have in database, so just make your life easier and type default. So now we have to enter the first name. I'm gonna use, for example, the first name, Anna. Here we have problem in SQL database that you cannot just type the first name like this. It is a string, and in string we have to put it always inside single quotes or double quotes. So for example, I'm gonna use the double quotes in order to deal with the strings. If you don't do that, you will get an error. I usually use one quotes to insert the strings. So with that, it should be okay. The last name is the same thing, it is var character, and we have to put a name on it. So I'm gonna use Nixon as last name. So we have now the 3 columns: customer ID, first name, last name. Now we have country and score. So let's check the country. The country, it says it is var character, so we have to specify something over here, and we could leave it empty. So I don't have here really to insert anything if I don't want. And the same goes for the score. It is but integer, but we could leave it as well empty. So what I'm gonna do, I'm just gonna add the country. So the country, it is var character, so it is string. I need to put it in single quotes. I'm gonna use the country UK. Okay, so now to the last column, we have the score. So let's check that in the description. So we have score, it is integer, so that means only numbers should be inside the score. It is nullable, so I could leave it empty, and it is not primary key, and so on. So that means I could leave it as a null. And that makes sense because Anna is a new customer and she doesn't have yet any like scores in our database or system. So that's why I could just write over here a null. Or I could leave it like a 0 if I want. So with that, I will just leave it as a null. And let's just execute now the query and see whether we have everything right. So here we will not get any like result sets. We will just get here the information that everything is green and we have inserted the data. So in order to check now this user inside our database, we're gonna open new tab, select star from customers and see whether Anna is in the database. And yes, we have one more customer called Anna Nixon from country UK. The score is null, she's new, and we have the new generated ID, customer ID from the database. Okay, so now let's keep practicing and add one more customer, our customer number 7 in our database. So let's go and do that. So I'm gonna remove everything and start from the scratch, insert into our table customers, and now we're gonna add the values. So as usual, our first value, the customer ID, is gonna be default. The first name, I'm gonna use Max, and the last name, I'm gonna use Lang. But now the country and score, I could leave them empty, so I'm gonna use the null, and as well for the score null. So now, as you might already notice, what I've really done over here, I just gave a first name and last name. And for all others, I'm using some nulls and defaults. So we could like skip that and make our life easier with just adding the first name and the last name. So if I just remove the null over here and the default and run the query, I will get an error because the database is not understanding what is Max. Is Max like the country? Is Max the first name, the last name, the Lang as well? Is it like the first name, last name? So we need to specify for the database what are those values to which column. So in order to do that, I'm gonna open here new brackets and say, okay, I'm gonna type the column name, first name, and the second one, we are using the last name. So with that, we are telling the database, okay, the first values belongs to the column first name, and the second value belongs to the column last name. And if I run this, we will not get an error because we have already done the mapping and everything else is done automatically. So that means the database knows the customer ID, it is like automatically generated. So it's going to generate a new ID. And since the database didn't find any information about the country and the score, it's going to put it as a default as a null. So let's check now the result. If I query now the same, select star from customers, and we can see the database done that and inserted our new customer Max Lang. She understood that the country, or it understood that the country is a null and score is a null, and generated the ID of 7. So as you can see, it's more compact and I don't have to add all those nulls, because imagine if you have a big table with like 50 columns and you have a lot of nulls, the query gonna look really bad. So here I'm just inserting what I need and the rest gonna do the database for me if it is allowed. So for example, if the country should not be null, I have to insert here something about the country, but since we are allowing the nulls in the country and the score, we could just ignore it and leave it like this. And the task is just to add the country Germany to this record. So now we have to update the content of this customer by changing the null to Germany. So now we're gonna start with the keyword update. And now we have to specify the table name that should be changed. So we're gonna have the table name customers. And after that, to the new line, we're gonna have the keyword set. With that, we're gonna specify new values for the columns that should be changed. So we want to change the column country, and we have a new value. Instead of the null, we need to give the value Germany as a new value for that country. Now here you need to be really careful about that. If I execute this, don't do this. If I execute this command, what's gonna happen? The database is gonna go and updates all the values for all customers underneath the country to the new value Germany. Because if you read this, we are telling the database That's update the table customers and set country to Germany without specifying any customer. That means if we run that, all the countries will be in the table as Germany. So don't do that. Our task is here is only to change it for the new customer. So as you can here see, our customer max has an empty value at the country and we only need to change it. So in order to do that, we're gonna filter or we're gonna put like condition for the updates. And in order to do that, we're gonna use the primary key customer ID number 7. I don't recommend to use any other columns like, for example, the first name or the last name, because if you have a big table, the first name max may be presented in other customers. So maybe you have different customers with the same first name. And if you run the query on the first name, all customers with the first name max will have the country as Germany. So to make sure to update the right record, the right row, we're gonna use the primary key, the customer ID, in order to do that. So let's go back over here. And we're gonna write the where command exactly like the select. And we're gonna say, we need to change the customer ID number 7. With that, we are telling exactly the database we have now new value on the country, and that is only for the customer ID number 7. So let's run this and go over here and run this again to check the value. So here we have it empty or null. And after the updates, now we have Germany inside the country. All right, let's have another task where we're gonna manipulate and update the content of our tables. The task says, our new customer Anna, she was active. She bought something in our website and she has now the score of 100. So instead of having the score of null because she was a new customer, we have now 100 for Anna. And not only that, we have entered by mistake the country UK instead of USA. So Anna comes from USA and we have to update as well the country. So let's do that using the update command. All right, so we're gonna check over here. So before we start like updating the values in the columns, let's go and make it sure that we have the right customer. So we are not updating different customer or updating the whole table. So let's make sure that we are selecting everything right in the where command. So Anna has the customer ID number 6. So instead of 7, we're gonna write here number 6. So now we are focusing on the right row. And now the country should be USA. So now we are giving a new value for Anna in the country field. And we want now to specify one more column to be changed. So in order to do that, we have the comma. I like to put it in a new line. And the score should be equal to 100. So with that, you are specifying like multiple columns in one update. And you can split them by the comma. So if I want to change one more column, I could do it all in one command. I don't have to have like different command for each column. I could put everything in one. So now what we are saying, update the table customers, where the customer ID is number 6, and the country should be equal to USA, and the score should be 100. So let's run this. And then go back to our select star from customers to check whether everything was okay. So I'm gonna refresh that, and you can see now Anna has the country USA and the score is now 100. So it's pretty easy to manipulate the data using the update command. Customer Anna and the customer Max, they should be deleted from our database, from our tables. So in order to do that, it's pretty simple. We're gonna use the command delete. All right, so in order to solve that, we're gonna write very easy commands, and as well, it is very dangerous. So we're gonna start by writing the keyword delete from, and then comes the table name. So we need to delete from customers. As you can see, it's only 3 words. It's very easy, but if I execute this, be careful with that. It's gonna delete everything inside the table customers. So I'm not specifying anything. I'm saying delete from customers. And if I run it, the database is gonna delete all our customers from the database. So be careful with that. Always specify what do you want to delete exactly. So with that, it's like the updates. We're gonna use the where commands and use the primary key, the customer ID. So we want to delete the customer ID number, let me check again, number 6 and 7. So in order to do that, I'm gonna use the in operator in 6, 7. So any customer IDs in 6 and 7 gonna be deleted. So this is my filter condition, and if I run this, both of the users gonna be deleted. So let's check that. If I run this over here, you can see both of the customers are deleted, and with that we have deleted some records from our customers. But be really careful what you are specifying in the delete. Create a new table called persons, and inside it we're gonna have 4 columns: ID, person name, birth dates, and a phone. As you know, in our tutorial database we have only 3 tables. So if you check here the left side, we have the customers, employees, and orders. And now we're gonna add one more table called persons. So let's do that. All right, so now let's start creating our table. We're gonna start with the commands create table, and after that we need to specify now the table name. But before that, we have to enter the database name, or in other databases it is the schema name. So as you might already notice, in MySQL we have different databases. We have our tutorial database and some default ones. So we're gonna put this table in our tutorial database, and that is db_SQL tutorial, then dots, and here we're gonna put now the table name, and we have the persons. After that, we're gonna open 2 brackets, and inside them we're gonna define now the column structure. So let's start with the first column. We have the ID. This is our primary key, the most important like column in the whole table. It's something like the customer ID in the table customers. So the name of it gonna be ID. After that, I'm gonna have space, and then we have to define now the data type. Since it's gonna be sequence of numbers 1, 2, 3, 4, and so on, we're gonna use the data type integer int. I will not define the size. I'm gonna use the one that we have as a default from MySQL. So now we're gonna define the constraints that we want for this column. So here, since it is our primary key, we're gonna use the constraint primary key. We don't have here to specify not null, because as a default, if you are saying this is primary key, you will get inside it 2 things. First, it's gonna be unique, and as well not null. So it is 2 constraints in one, the primary key. So after that, I don't want to generate those IDs by myself manually by doing the inserts. I want that the database take care of that. So to do that, we're gonna define it as auto increments. So with that, if you are using default or you are not specifying anything in the insert statements, the ID gonna be generated automatically from the database. So with that, I have the column name, I have the data type, and I have 2 constraints. So now we're gonna jump to the next column. We have the person name. So I'm gonna add comma and a new line for that. So here we're gonna have the person name as a column name, space. After that, we need to define the data type. So since it's gonna include some characters and so on, I'm gonna use the var char and define as a size 50. So more than 50, the data gonna be cutted and inserted in the database. So this is my rule. As well, I want that each person has a name, so we don't want to have some nulls. So now we can define the constraints. So this should not be a null. So that's it. I don't want to have some unique constraint and so on. So we allow that we have 2 persons with the same names, but they will have different IDs. So that's enough for this column. We're gonna jump to the next one. We're gonna add the birthday. So the name of that gonna be birthday space. The data type of that's gonna be date. And now I don't really want to specify any constraints because this column could be optional, so we will not add anything. So that should be enough. We have the column name and the data type of that. So comma, and the last one, we're gonna have the phone as a column name. The phone could be like characters as well. So varchar, varchar, and I'm gonna allow only 15 characters to be inside the phones for some data qualities. So the phones should not be in null. So here I'm gonna add a constraint not null. And one more thing that I could add as a constraint on this table is that each person should have a unique phone number. So we should not have two persons with the same phone number. In order to force such a quality at your table, we could add the unique constraints. And with that, we are telling in this column, we should have only unique phones and duplicates are not allowed. So now we have all our 4 columns. We have specified the data types and the constraints, and that's it. We could run the query over here. So we don't have any errors. If we check on the left side, we don't have yet the person. That's why, because we have to refresh the data over here. So click on refresh and you will see we have one more table called persons. Okay, so now let's check some stuff. For example, if I go and say select star from persons, just to check the table structure. So here I can see, okay, I have a table called persons, I have my 4 columns and everything is empty. You could go and as well check the describe command for persons and query that, and you can see, okay, we have the fields, the data types, what is null, what is not null, the primary key, and what is unique, the auto increment. So you could check that everything is fine and as wanted. We need to add one more column to our new table persons, and that is the emails. So in order to do that, it's pretty simple. So we could use, I'm going to remove this. We could use the keyword alter table and the table name persons. And after that, we're going to add the keyword add. Now we are adding a new column. It's like in the create table. So we need the column name, and that is email. Then after that, we need to define the data type. It's going to be varchar 15 as well as rule. And here as well, we need to add some constraints. If you want for some data quality, you say, okay, this is not null. So with that, I'm changing now the already existing table that's called persons, and I'm adding now a new column. So let's run this. And let's check again our table, refresh. Let's select the table persons and see the results. And as you can see at the ends, we have a new column, and always SQL gonna add the new columns at the ends. So if I check this as well, describe persons, just to make sure that everything is fine, we can see here we have one more column that's called emails, var character 15, and this should not be in null. So let's say we want to drop the new table that we have that's called persons. So we use the keyword drop table and just write down here the table name, and that's it. So once you execute that, the table persons will not exist at your database. So I'm gonna delete it. And as you can see on the left side, you will not have the table persons. So it's really simple. And if you like this video and my work and you want to support the channel, then subscribe, like, and comment. And in the video description, you will find a link to free SQL materials like the database and the data of this tutorial, the SQL sheet, and as well all the presentations. Thank you so much for watching, and I will see you in the next tutorial. Bye.